So the 4% inflation means whatever the price was last year, the price next year is going to be 4% higher. Right? So drawing a picture of what that looks like, we need to draw a square or a rectangle that represents 100%. Percent here. And then we've got a 4% increase. So I'm just going to roughly estimate the 4% increase on here. So let's say that's my 4% increase. So this now represents 104%. Let's try again. 104%. So I'm given $1 amount here, the 520. So does the 520 belong to the 100%, or does it belong to the 104%? And let's just think about the whole last year and this year. Inflation moves from past to future, past to present, or present to future. So the 100% must be last year. Java. And the 104% must be the current for this problem. So that means the 520 has to go with 104%. So this number right here is $520, and then our missing number is right here, and that's the original amount. So we don't know what that is. So if I want to set up a proportion to solve this, I can. And so usually for the proportion, I like my part over whole. Actually, no, part over whole won't work because this is an increase. Try that again. I'm going to go old over new. And I'm going to write the percent one first. So the percent, the old percent, that'd be last year, that's the 100%. And the new percent is the current, that'd be the 104. Where does the 520 go in the dollar? So this is my percent fraction. Where does the 520 go in my dollar fraction? Top or bottom? New. So it goes in the bottom. So the 520 has to go down here. And then the missing number goes up there. And so now I have a proportion that I can use to solve this. So then I'm just going to, you could do the cross multiply and divide trick to solve it. So do that and see what you get. And then we'll look at it a slightly different way. So ultimately on that, I'm going to multiply the 100 times the 520. Digit. And then I'm going to have to divide the 104 back. And when I do that, I get 500? Yeah. Exactly. Right? So I said it was supposed to come out to a nice number. So this says $500. So that's one way to do this problem. The other way to do this problem would be to say, this chunk that I added on here is a 4% chunk, right? Can I break the rest of my bar up into 4% chunks? Does 4% go nicely into 100? The answer is yeah. How many 4% are in 100? $25, yeah. So if we take the 4% into 100, so let me just do this in red maybe, differentiate it a little bit. If I take that 100% and divide it into 4% chunks, then I'm going to get 25 pieces. So this 100% is 25 groups of 4%. Plus, I have that 4% on the end, so how many 4% chunks are there altogether? 26. So another way to solve this would be to say, we'll figure out just how much a 4% chunk is worth in dollars. So what's 500 divided by 520 divided by 26?
20.
What is it?
20.
Yep. So each of these chunks here is worth 20. So another way to think about this right here is I have 25 groups of 20. And 25 groups of 20 is? 500. Okay. So this was the way we looked at it. We had two different ways to look at it last time. We can try and break up this into equal sized pieces, or we can set up a proportion for it. Now, a common thing to do is just say, hey, I get a percent and I get a number, let's just multiply them. Now, it's not always appropriate to multiply two numbers. So, the wrong way would just be to say, hey, I got 4% and I have a number, 520, why not just multiply them? And it's a starting point, but then you have to double check to see if it's right. So, what is 4% of 520?
2080.
2080? So we are guessing that that is the amount of increase. So then I would take that away from the 520. $80, and that's going to give us what, 490.20?
499.2.
499.2, yes. So we're guessing that this is the last year's price. How would we check it? Don't we know what inflation is? What's the inflation amount? Percent, 4%. So we should be able to take that 499.20, multiply it by 4%, and then add it back on to the 499.20. So whip out calculators, let's check to see if that works out okay.
I did that and it gave me a lower number.
Yes.
I think it was like 529.
Okay. So whip out your calculators, let's double check it. I'm going to bring up a calculator too. So we have this number 499.20, and we want to know what is 4% of that. And then we want to add back on the 499.20. And I get $519.17 if I round, which isn't the right amount. I should get back the number I started with. Okay, so that doesn't quite check out. 519.17. So that's an indication that I made a mistake because it doesn't quite check. Almost, but not quite. Now, it's almost for a couple reasons. One, 4% is not a big percent, and we're only looking 1 year back in time. If it was a bigger percent and we were looking farther back, then we would have a bigger discrepancy than the actual answer that we started with, which was the 520. So this check right here actually tells me the right way to do it. The right way to do it would be to take the last year's amount and multiply it by 4%, and then what? Once I get that percent increase, what do I do with it? Add it back on. And that right there is how I calculate the 520. What does the 4% get multiplied by? The 520 or something else? Something else, last year's. The thing to note here is that this part right here represents us using 4%, and this part right there represents 100% of the thing we're acting on. So altogether, what's our percentage? 104%. So the other way to think about this is out of 104%. So if we knew last year's price and we multiplied that by 104%, 1 in 400ths, that should give us the 520. So this is another way to think about that problem. Thinking about it out of 100%. And we did this last week for percent increase and percent decrease. And there were a few homework problems about it. How do I finish off this?
You drop.
I do what? I want to use this to solve, figure out what the answer is. What am I going to do?
You divide the 104%.
Yeah. I'm going to divide the 104% over to the other side. So double check on your calculators. What is 520 divided by 104? 1.04. Should be exactly 500. So 520 divided by 1 in 400ths is exactly 500. Now, we actually already had this method in front of us immediately, and we didn't choose to use it at first. What happened when I drew that picture first? What did I get right away? Yeah, the first number I wrote down was the 100%. The second number I wrote down was 104%. And then I had to figure out that the 520 went with that number right there. So that picture actually leads directly to the answer. Okay. So this picture allows me to do two things. It allows me to set up a ratio if I want, and a proportion. Or that picture can jump me straight to this other method of solving right here. Realizing that we need that 104%. All right, we're about to make this slightly harder. Ready? We're going to try to consider what happens with 2 years of inflation. We have everything we need to figure it out based on the last problem we did. So the new problem I wrote on the board over there, which I'm going to put up here for our future audience, is now we're going to suppose a dryer is currently worth put it over there, $450. What was it worth 2 years ago?
Are we still using the books?
Still using 4%. Yeah, still using 4%. So what was it worth 2 years ago with 4% inflation? All right, so this is like the last problem, but there's an extra step in it. Play around. This does not come out to a nice number like before. This one is harder to draw a picture of. I'm not asking you to draw a picture here, but you can if you want. One problem with the picture, it's a little bit limited. You can only look at last year with the picture. Picture only handles 1 year at a time. See a strategy based on that? Do last procedure twice in a row. Give it a shot. Come up with a number. You need a calculator for sure, and to write some stuff down. Oh, I mistyped that. I get last year it was $468. Can you find the year before now? Oh, no, times and mistakes.
460.
I did that wrong. I forgot to divide. That doesn't make sense, does it? Divided by, oops, 432 rounded to 69 cents. Anybody think they know what it was 2 years ago? It's okay to be wrong because I'm going to learn how to fix it.
I'm 67 cents off.
You're in this one right here. How did you go about solving it?
Well, I divided it by 1.04 and I got the 432.69 and divided that by 1.04, which would be the second year.
Yup.
And then I got 416.05,
Yes.
which is $34.62 if you.
Now we had to round twice in a row, right?
Yeah.
So you're correct. That's to round it to the nearest cent. That's the right answer. So 2 years ago, it should have been $416.05 to the nearest cent, and you have to round, right? We don't charge people fractions of a cent. We hardly even use cents anymore, but they exist in calculations. So just going to show a couple things on my calculator here. What's that? Why 5? So there's a couple ways to look at it. So, okay, so you have an error in that calculation somewhere. So let's just go over this for a sec. So up in the search bar at the top here, I typed the 432.69 and I just said please divide by 1.04 again. And that gave me 416.048 blah blah blah, okay, which we rounded to 416.04. Now, another way to think about this is pretty much every year that goes by, pretty much every year that goes by, the inflation multiplier is 1.04. Every year that goes by. So if 5 years went by, how many times would I multiply by 1.04? 5 times. Okay. So only 2 years went by. So if 2 years go by, I take whatever the old amount was, and I multiply it by 1.04, and I multiply again by 1.04. What would happen if 5 years went by? We said we would have to multiply how many times? 5 times. So if 5 years went by, I would take whatever that old price was, and I would multiply by 1.04, by 1.04, because inflation does this same action every year. 1, 2, 3, this is getting tiresome. Is there an easier way to write this? I'm getting kind of tired here.
Do you write to the fifth power?
Oh yes, that would be so much better. So this is the same thing as the old one, times 1.04 raised to the 5th power. What about the one above? Could I rewrite that using exponents? What would that one be?
All times 104 to the second.
Yeah, the 2nd power. So if I make that observation that I can do that, then I have another way to solve this problem. And it looks like this. I don't know the old price, but I know inflation would have to act twice, so that means I could simplify it down to that right there. And the result of that would be that $450. So if I want to get the old price alone, what do I do to solve here? How do we break a multiplication? Divide. So I would divide by 1.04 squared. So whip out your calculators, take the 450, divide by 1.04 to the second power. Let's see what we get. So I'm going to bring up a new tab for that. 450 divided by 1.04 raised to the second power. I get a slightly different but similar number, 416.05. The rounding is different. Is it close enough? So last time we introduced rounding twice in a row. Here we're only using rounding once. This answer is a little bit more accurate, but to the nearest cent it looks the same. Is everyone getting the same number there? 416.0502 blah blah blah. Now, we only deal in dollars and cents, so we're introducing rounding error once we say the answer is 416.05. So we're going to just double check to see how close we are to the answer. If we take our 416.05 and we multiply that by 1.04 to the second power, we should get pretty close to $450. Are we close enough to the nearest cent? We're as close as we can get. Rounding error happens in complicated calculations, and there's no way to avoid it. Do all fractions make nice decimals? Nope. We're going to revisit that idea today too. So it turns out when you do have a repeated percent increase or a percent decrease, what happens is you get that out of 100% multiplied over and over again. And it turns out it's not that bad. But it's a little bit different. The pictures don't apply directly if we do 2 and 5 years. The picture way of solving is just kind of like a 1 year thing, unfortunately. Trying to draw the picture for these is way more complicated. All right, homework questions. Let's see. If you have homework questions on what are we set? What chapter are we on now? 6, there we go. 6-4, we're going to go over that. Did anyone have any trouble with the ratio, percent, and scientific notation? Okay, which problems?
The scientific notation part, because I tried to watch it, I just was not getting it correct.
Okay, so let's take a look at a few of these. Was there a particular one you found disturbing?
It was like number 4 or 5 or something.
Write this number in scientific notation. Take this number and write it in decimal notation. Does that look like the kind of problem? Or no?
Yeah, I mean, I stopped because I could not figure out. I think it was a scientific notation because I did fine on the first few, and then even after like rewatching it, I was just like, okay, I'm just not getting it.
Yeah, we'll just do a couple of easy ones. So, for example, if I have the number 112.4, how do I write that in scientific notation? So just remember, numbers in scientific notation you can have only one digit to the left of the decimal place. So if I start with the number, let's see, what was it, 112.4. Then what I do is I rewrite the number with just the digits, and I put the decimal point where I want it to be. To be in scientific notation, it has to go there. Okay? So this number I started with is bigger, so that means I'm going to be multiplying by some power of 10 that's positive. And I had to move the decimal point 2 times to get it where I needed it, so it must be 1.124 times 10 to the second power. Positive exponents mean I have big numbers. Negative exponents means I have little numbers, fractions, proper fractions. So that would be the answer it would be expecting there for me to write this right here. Now, I could, if I want, put the decimal way over here then this would be, oops, times 10 to the third power. This number right here definitely equals both of the numbers above, but is it in scientific notation? Now, this is what they call pseudo-scientific notation. It's got the right form, except that mantissa is a little bit off. It doesn't fit the results. The number that you write here, again, that's called the mantissa. It's got to be between 1 and 10, always less than 10. Can't have 2 digits to the left of the decimal. All right, let's try another one. Converting out of scientific notation is pretty much typing it into the calculator if you want, or you can do it without. So if we take a look at the next problem here, it gives us a number in scientific notation. We just have to figure out what to do with it. So 9.074 times 10 to the negative 2. So a negative exponent means I have a small number. So this is talking about the 10 to the negative 2 means I'm talking about hundredths. Right? 10 to the negative 2 is 1 over 10 squared. So just a reminder, negative exponents means flip the base, which means I'm talking about hundredths. So I'm describing a number in scientific notation that's in the hundredths. That means I have to move the decimal point this direction. How many times? 2 times. So I move it once, I move it once again, and that's where the decimal goes. It tells me I need to fill in 1 0. So when I rewrite it, I like to put a leading 0. The 0 I had to fill in, and then the 9074. What position is the 9 in? The hundredths position, which this identified for me. If you're not sure, type that into a calculator, see what happens. We need to be good at using calculators too. Something we should teach in schools, how to be an awesome calculator user. So I'm just going to type, what's it again, 9.074. 9.074 times 10, find your power button, negative 2. Warning, on some calculators you need a parentheses for the negative 2, but it depends on the calculator. You got to test yours out. And so it gives me the right number there. All right, let's see if there are any other goodies. Other problems were multiplying and dividing. And the catch on that is these are mostly calculator problems, although you can do them a little bit without. But I was pretty much thinking you would plug it into a calculator and then just convert to scientific notation. So let's pick one of these to do. Let's do this one right here. Blow it up a little bit. Actually, I'll copy it to my screen. All right. What is the result of this in scientific notation? I highly recommend a calculator. It's not absolutely necessary, but it does help. Write something down, type something up. All right, got an answer? What do you think, Jimmy?
I got 8.58 times 10 to the negative 28.
8 points, what was it again? 58
58, yeah.
times 10 to the negative 28th power. Okay. Anybody else get that?
I'm not sure if that's right. I just did 6.6 times 1.3, and then I subtracted the exponents.
Yeah, so one cool thing about this, I just have a bunch of multiplication, and multiplication has a property called the commutative property and the associative property. Those two properties together let me move the parentheses and move the numbers. So I could rewrite this as 6.6 times 1.3, and I can calculate that part. And then I can take the 10 to the 12th times 10 to the negative 40. We have a rule that says if you have the same base being multiplied, then you get to add the powers. So that's going to be 12 plus negative 40. And 12 plus negative 40 is negative 28. So I get a negative 28 there. And then I'm assuming then 6.6 times 1.3 is 5.85, or 5.58, excuse me. Or 8, oh wow, so that one. 8.58, there we go. Not too bad. And you can type this into your calculator exactly as you see it. Division's a little trickier. So let's try division. Next one should be division. Nope. Nope. Oh, that one's a cool one. We'll go back and look at that. Here's a division one. All right. Oh, that one's pretty easy. That's okay. We'll do it anyway. Couple different ways to do this one. My recommended way would be just plug it into the calculator. That's okay. But then we got to get the answer in scientific notation. And just because it started in scientific notation doesn't mean your calculator will put it in scientific notation.
Mine said 6.6 E plus 12.
Ah, yes, that E thing. So E means times 10. And the next thing is the power. All right, so let me get a calculator up here.
Just put 6.6 times 10 to the second. Doesn't matter, right? Do we have to have 3 digits? No, because it's at least.
Yeah, so if we follow the rule I talked about last time about significant figures says you use the least amount of figures in the numbers you were given. So I have two numbers that I'm given in the mantisses. One has 2 digits, the other has 3 digits, so my answer should have 2 digits. When I typed this into my calculator, I got that the answer was 6.6 times 10 to the 0.
Zero.
To the 0. You get 10 to the second?
Yeah.
Okay, so let's break this down a different way. If you think about the way we multiply fractions, we multiply across the top and multiply across the bottom. I can unmultiply this by saying this is 6.4 over 9.65 times 10 to the second over 10 to the first. Okay. So then I can deal with each of those separately. Let's deal with this one right here because it's easier to do in our heads. What's 10 squared divided by 10? 10 to the 1 or just 10. So that's a 10 right there. Now this, I don't want to do that by hand. I'm going to whip out a calculator for that. So then we whip out a calculator. So my calculator over here, 6.4, oops, I'm not typing in the right spot, 6.4 divided by 9.65. I get 0.6632. Now I'm going to go with the significant figures idea. I'm only use 2 of those digits, which would be the 6.6. So I get 0.66. Is this result in scientific notation? Answer is no. If it's not in scientific notation, I'm not sure how to easily shift it. I just do the multiplication and see what happens and then put it in scientific notation. So I multiply these together and I get 6.6. Okay, well 6.6 fits the ideal mantisic, right, because there's one digit to the left of the decimal. Then the only thing I can multiply by is 10 to the 0, so I leave it alone. Because 10 to the 0 is really what number?
1.
1. So that's the correct answer. Now, for those of you who ended up with a 10 squared, here's what went wrong. Order of operations. This big fraction bar implies you need to calculate the top and calculate the bottom before you divide. How many people's calculator has a fraction bar that looks like that, horizontal? Some do. I don't have one on me. So in order for me to type that into my calculator, I would have to type it like this. Put it over here in blue. 6.4 times, parentheses, times 10 raised to the second, close parentheses, divide, parentheses, 9.65 times 10 to the first. So now try it with the parentheses, see what you get.
So
Just
what
double check.
So I didn't do it either. I tried. I messed up because I just broke up the problems separately. So I did 6.4 divided by 9.65. So I got
So you got the 0.66,
Yeah.
blah, blah, blah.
And
Okay.
then I did 10 squared divided by 10 over 1. So then I got 10. Then I just got 10 over 10 to the 1, or just 10.
It should be just 10.
Yeah. So
Yeah.
then I got
So that's this
0.6
right here.
Yeah, then I got 0.66 times 10. And then I was like, well, I need to move it over 1. So I need to add. So since I moved the.
You went the wrong way. Yeah,
Yeah.
if you move the decimal this way, you would increase that. But if you move the decimal that way, you're going to decrease that. So it should have changed from a 1 to a 0, not a 1 to a 2.
Yeah.
But yeah, that was a
Yeah.
good strategy.
Yeah, that's
It
where
just
I went wrong.
so every once in a while that direction confuses me. So what I do is I just multiply all of that out and then start over.
Okay.
Put that in scientific notation.
Yeah, okay.
So just a note on what went wrong if you got the 10 squares. That was one way it could get wrong. The other way it could go wrong is by skipping the parentheses completely and just entering, someone needs to be red, 6.4 times 10 squared divided by 9.65 times 10 to the first. So what's the order of operations here? What has to happen first? Well, the first order of operations, since there's no parentheses, are exponents. So what the computer's going to do is it's going to say, okay, that 10 squared is a 100, and that 10 to the first is a 10. And then it puts the other stuff back in, and it says, okay, what do I do next? What should it, I forgot to multiply here. What would the calculator think to do next? Multiply or divide first? Why multiply first? You don't always multiply first. Why not?
From this way.
You have to go left to right. Yeah. So now that it's only multiplication and division, that's line 3 of the order of operations, the calculator just goes left to right. So then what it does is it multiplies here, then it divides here, but then it multiplies by 10. But where is that 10 really supposed to be? It's supposed to be in the divisor. And if you don't put the parentheses in there, it gets to be a multiple. So your answer ends up 100 times bigger than it should have been. Yeah. So bottom line, if you have a complicated fraction and you're using a calculator, put the top in parentheses, put the bottom in parentheses. Okay? All right. Let's take a look at the last problem, then we need to move on to the Pythagorean Theorem. Show desktop. All right, the last problem I put in here as a challenge to you guys. I did a similar problem in class. We were playing around with the sun versus the earth, relative sizes. And here you just kind of got to read the directions carefully and follow the directions. So first thing, they give us this formula for the volume of a sphere. And actually, let me pop this into a new window so it's more easily, oops, there we go. More easily readable. And if you didn't finish this, you can apply a late pass. So, volume of a sphere is this formula. We went over that formula last class. The catch here is that we also want to play around with the radius version of it. So we have to solve that. And that was a wee bit tricky, but I gave a bunch of options for which formula is the right one, and the computer eventually tells you which one's right if you don't get it first time you try. So let's do that together right now. So for a sphere, volume, we'll play more with this next quarter, the formula is 4/3 times pi times the radius to the third power. And the sphere is a ball. And so the only thing we need to know to calculate the volume or surface area of a ball or a sphere is just what's the distance from the center to the edge. The diameter would be good too, but then we have to cut it in half to get the radius because the formula requires the radius. If I want to solve this for the radius, if somebody gives me the volume and I need to figure out what the radius is, then I just have to get everything away from the r. So the first thing I would get rid of is the 4/3. Easiest thing there to do, instead of dividing, multiply by 3/4, the reciprocal. Because remember, isn't division multiplying by the reciprocal? Right, that was one of our rules. So I have to multiply by 4/3 on each side. So I have 4/3, let's see, if I consider 4/3 times v over 1, then I could rewrite that as 4 times v over 3. So I could either call it 4/3 v, or I could call it 4v over 3. Two different ways to think about it. On the other side, now here, the 3 is divided out. 3 divided by 3 is 1. The 4 is divided out. 4 divided by 4 is 1. I'm just left with pi times the radius cubed.
Wouldn't it be 3v over 4 since you said?
Oh, shit. Oh, shoot. Yes, you're correct. I got my 3 and my 4 upside down. Job. Spread first 3 over 4, and then 3v, oops, 3v over 4. Okay. And then I need to get rid of the pi, so I'm going to have to divide by pi. Now this is a bit complicated on this side because I have a fraction within a fraction. How do we deal with division with fractions? Multiply by the reciprocal. What's the reciprocal of pi? 1 over pi. Yeah. So this gives me 3v over 4 times 1 over pi, which, given the way that we multiply fractions, is going to give me 3v over 4 pi. And then I was hoping that you guys remembered from a past life in math, how do you undo a cube? What it? Not square root, that is a square. Cube root is what we do instead. Yeah. So what I want to do is take the cube root of each side. So it looks like a square root, but it's got a little 3 in the hook there. So I got to do that on this side. And some of the formulas have that as an option. And so I was hoping either by doing some algebra or trial and error, you found the right formula. So then, if I can keep my 4 and my 3 in the right order, it's 3 on top and the root. I believe I want this one right here. 3 times the volume over 4 times pi. So if somebody gives me volume, I can use this to figure out the radius. And then we're just going to play around with numbers that are in scientific notation. So this time in class, we compared the Earth to the Sun. This problem compares the Earth to the Moon. So this says the Moon has a radius of 1,738 kilometers. That doesn't need to be in scientific notation. It's tolerable like that. But it says, find the volume and make that scientific notation. And then it says using 3 decimal places in the mantissa. So we just need to plug that into our original formula because we're given the radius. So whip out a calculator, plug in 1,738, and let's see what we get. Let's see, calculator, clear. So I have 4 divided by 3 times pi times 738 raised to the power of 3. My calculator says it's a great big number. copy that into my screen so we can put commas in it. So moon radius R equals 1738 kilometers. The volume is 4/3 times pi times that number cubed. And my calculator says, paste it in, it's this number right here. So commas, 1, 2, 3, 1, 2, 3, 1, 2, 3. I'm getting 21 billion, right? Thousands, millions, billions. Anyone else getting that? If I take kilometers and I cube them, I get cubic kilometers. That's a measurement in volume. Which we sometimes write as km cubed, cubic kilometers, 2 different ways to write it. And I'm supposed to put this in scientific notation with 3 decimal places in the mantissa. So I think that would be 2.199. And then I just have to figure out what power of 10 that's going to be. So I want the decimal to be right here. We just have to count how many places that was. So what do we count? 1, 2, 3, 4, 5, 6, 7, 8, 9. Is that 10 places?
Here.
So then that should be an approximation of the moon's volume, according to
So if we wanted this to
criteria.
go to the other side, we just would make that negative, right? For-
If it was a small number that we were starting
like
with,
the 100, like the-
so for example, you're saying if we had a number that looked more like this,
Yeah. For more than 20.
and we wanted that to be in scientific notation, then I would rewrite it as 2.56, and then I would count how to get from there to there. So 1, 2, 3, 4, 5, is that right? 1, 2, 3, 4, 5. Yeah, so this would be times 10 to the
Negative.
negative fifth. Yeah. Yeah, so negative exponents taught in scientific notation help us describe small numbers. That's a pretty small number. Tenths, hundreds, thousands, 10,000, 100,000s. What's next? Millions, 10 millions. So 256 10 millions. It's pretty small. Okay, so big numbers, positive exponents. Yeah, so that's the number I was expecting here. Next question. So that's this one. Next question says, this is the volume of the Earth. What is the radius of the Earth? So they want us to use the formula above to figure out what the radius is. Okay. So we plug that into the formula. We get a number. This time, it doesn't say scientific notation, so I wouldn't worry about it. But you probably could put it in scientific notation. And then here's the hard part. Finding the ratio. How many times is the Earth's radius is blank times the moon's radius, and the Earth's volume is blank times the moon's volume. So right now, I know the Earth's volume and the moon's volume, so I'm going to go do this last one with you right here. And we did one like this last time. So I'm going to copy that question into my screen. Let's see, where's my copy button? It is right here. So this is the question we're trying to answer. We know the moon's volume right there in red. The Earth's volume I'll put here in green. It was given as about 1.1 times 10 to the 12th, and again in cubic kilometers. So if it says km cubed, read it as cubic kilometers. This is the way to write it. Okay, so let me see. The Earth is blank times the moon. The Earth is bigger, true? Yeah. This is 10 to the 12th power. That's 10 to the 10th power. So it's not quite 100 times bigger because this is a 2 and that's a 1. So I would like you to whip out your calculator and see if you can take these two numbers and come up with an answer for that question. I'll show a couple different ways to look at it to come up with the right math. Hint, if you do a division, use parentheses on your calculator. Anybody get an answer? Yes, but you're afraid to say.
Yeah, because half the time I'm wrong.
That's okay. That's how
one
you.
thing wrong. and
That's
it's
how
like,
you learn. I'm wrong almost all the time. Ask my wife and my kids.
2.41 times 10 to the second.
I don't think so. So that would be like 200 times bigger. Is that what you got?
1 and 99 thousandths.
That would be too small because the Earth is bigger.
Times 10 to the
Oh.
second.
Times 10 to the second.
Yes.
That seems too not quite big enough. Anybody get a different number? Okay, so let's see what I did. So I took, it's kind of hard to see. Can I blow it up a little more? Can you see what I did? So I want to take the Earth's volume and divide by the moon's volume because the Earth is bigger. And I'm comparing the Earth to the moon. So the Earth was 1.1 times 10 to the 12th. And I want to divide by the moon, which was 2.199 times 10 to the 10th. And whenever you divide numbers in scientific notation, you got to put them in parentheses. Otherwise, the computer confuses the order of operations. So I get the Earth is 50 times greater than the moon. Okay, can you try on your calculator again, see if you can get that, just to make sure?
Yeah, mine's double. Mine
Okay.
is that.
You had what, double that?
Yeah, so
Okay.
like if I do half, then it is that.
Okay.
So.
So we're going to do a rough estimate of this, just to see, because I plug stuff into the calculator wrong all the time. It's really easy to do. It's hard to plug it in right some days. So new page. So I've got, so for this comparison, basically the question said the Earth equals what times the moon? So if I want to solve for this multiplier here, I need to divide the moon to the other side. So if I make a literal translation of that sentence I was given, and then I solve for the missing number, I get take Earth divided by moon. So if I write 1.1 times 10 to the 12th, divide by 2.199 times 10 to the 10th, let's just do a rough estimate, right? Forget about a calculator for a second. And so just think about, isn't this about 1 divided by 2? Right? Which I could say is a half or 0.5. So I'm just going to say, oh yeah, that's about a half, 0.5. And then what happens if I take 10 to the 10th, 10 to the 12th, and divide by 10 to the 10th? What does that give me? That should give me 10 to the second power. And 10 to the second basically says make this bigger by moving the decimal point twice. So I have the decimal point there. I need to go 1, 2 times, which gives me that it's about 50 times. Yeah, so sometimes you can do a ballpark estimate by just, but I can't do all that in my head. Even estimating it that was a lot to think about, right? So I had to kind of break it down. First part's about a half. The second part's about 100. Half of 100 is 50.
So now I'm 1 off. So I don't know why I keep entering wrong on my calculator.
Like you got what, 51 or?
Yeah, this time when I did it.
Okay, so you must be just like mistyping one little part on your calculator. And again, on a regular calculator, I punch things in wrong. On my phone calculator, I'm always, like it depends on which one. The buttons are too close, my finger slips and hits the wrong digit. I hit multiply when I meant to hit divide. So yeah, I found my phone calculator a little painful to use. All right, I'm gonna stop this here and do a new recording.